Hello everyone, this is Robin. I have recently created a Python piano and connected it to MIDI, which is the standard interface for musical instruments electronically. This piano was based off LeMaster text Python piano, and I made a lot of modifications, optimizations, and add-ons. Now I will demonstrate what this piano is capable of. First, we shift the hand positions from the original, like that, and now I will play a little tune. You have to admit that was very impressive. So now let's look at the program itself, starting with the key lists. Next is what I call the shifting keys. First, we need to shift between octaves. V and B are right below the thumb on the keyboard, so I can shift it easily, like that. And also N and M are below the thumb on the right hand, so I can also shift easily, like that. Now these numbers, shift and 1 through 6, shift and 7 through 0, and dash equal, are for different hand positions within the octave. So if I press 1, as you can see, the borders shift by 1 note. If I press 2, then 3, 4, 6, it shifts throughout the octave. And an octave includes 7 keys on the keyboard, which means that every position is covered. If I press Shift, left shift, then it returns to point 0. The same with the right hand. 7, 8, 9, 0, dash, equal, and then shift. You have to admit that was very impressive. So now let's look at the program itself, starting with the key lists. So let us begin. First, we have the buttons on the QWERTY keyboard stored in 2 lists, right hand and left hand. Now, you could say I want to store them together so there will be only one loop. However, there are certain circumstances in which we need to think of the collision and overlap between the 2 hands, so we need to process them separately, and that is why they are stored in 2 separate lists. Next, we have a list that stores all the piano notes. On a standard 88-key piano, there are 4 keys that are outside of any octave, so I directly omitted those. And I also numbered them from -3 to 3, with the middle C as 0. Then we have 2 lists, black keys and white keys, that are just subsets or sublists, I guess you could say, of the piano notes. We store these separately so as to draw the piano properly. The left switch and right switch lists contain the labels needed for the shifting positions. And the white names and black names store the QWERTY key names for display on the piano. This tells you which key button on the keyboard corresponds to which note. Finally is the most important part, the dictionaries. First, the keydict maps a button on the QWERTY keyboard to a specific number, and numdict maps a number to a specific note. You will see that there are 2 extra keys in keydict. This is because when you want to play a complete octave, for example, 2 C's at the same time, or 2 C sharps at the same time, then you will need those two extra keys. This is also important because when you transfer it to a number, you can add or subtract in the program, and that simplifies a lot of things. Okay, so this is the piano main. It has over 400 lines of solid code, and although I included a lot of blank lines in between like this one, I would still say it's around the 430 range. Let us start from the initializers. First, we import some objects. Pygame is how the piano is run, and middle and message is how we send information to a MIDI port. That's musical instrument device interface. Then we import mixer, which is how the piano makes sound on its own. And we import the KeyLists as KL. Finally, we import OS and sys to make sure that when the piano is bundled as a single exe file, we can still play the notes. Then we initialize and set the number of channels to 50. Then we try to find a MIDI port. If not, we set MIDI to false. And we set up some fonts. Personally, I think Arial is enough, but if you want some fancy font, then you can refer to LeMaster video for that. Next, some constant. FPS is how many times you want the piano to check itself each second. And key width is the width of a single white key. Width here is the entire width of the display, and height is also the height of the display. Set up the timer, then display the window, and set the caption. Here is the operation variables. These are the variables we use to essentially run the piano. Active white and active black store the cycles remaining for each white and black key. We need to separate them because the white keys and black keys are drawn differently. Played. This list stores all the keys on the keyboard and whether they have been played in a previous cycle. This prevents the program from playing every note file from the start every time. In fact, every fraction of a second the key is held down. These 6 variables store the position of your 2 hands and the micro shift in each octave. Finally, this MIDI is basically a constant, storing whether your keyboard is connected to a MIDI port. Let us start from the initializers. First, we import some objects. Pygame is how the piano is run, and middle and message is how we send information to a MIDI port. That's musical instrument device interface. Then we import mixer, which is how the piano makes sound on its own. And we import the KeyLists as KL. Finally, we import OS and sys to make sure that when the piano is bundled as a single exe file, we can still play the notes. Then we initialize and set the number of channels to 50. Then we try to find a MIDI port. If not, we set MIDI to false. And we set up some fonts. Personally, I think Arial is enough, but if you want some fancy font, then you can refer to LeMaster video for that. Next, some constant. FPS is how many times you want the piano to check itself each second. And key width is the width of a single white key. Width here is the entire width of the display, and height is also the height of the display. Set up the timer, then display the window, and set the caption. Here is the operation variables. These are the variables we use to essentially run the piano. Active white and active black store the cycles remaining for each white and black key. We need to separate them because the white keys and black keys are drawn differently. Played. This list stores all the keys on the keyboard and whether they have been played in a previous cycle. This prevents the program from playing every note file from the start every time. In fact, every fraction of a second the key is held down. These 6 variables store the position of your 2 hands and the micro shift in each octave. Finally, this MIDI is basically a constant, storing whether your keyboard is connected to a MIDI port. Next is the initialization functions, or steps, whatever. The define resource path function is used because I would like to package this into a standalone exe file, and this ensures that the sound files packaged with it will still be able to be loaded correctly. Then is loading the sound files. Here, the block here. This uses the sound path, resource path function to generate all the sounds in the mixer for the keys. Finally, and this is a key step in this piano functioning perfectly, we generate the black positions and store each position in a prefix array. So this means that when drawing the piano or the key labels, we do not have to go back and start from scratch. This pre-calculates all the black key positions and stores them in a variable. So here we set up these 3 calculation variables and then we calculate it. That's simple. Next are the display functions, and I can tell you this is where the core of the program is. First is the tiny little display black function. This is used to package the process into a neat little line of code so that we do not need to write this over and over again. Now, the big one, the drawPiano. This is what draws the piano we see in the final product. First, we set up some text and set up the window. So as you can see, this is the instructions for switching the hand positions. Now, next we draw the white keys. A rectangle that is the white key and a black borderline. If the key is active, we also draw a green rectangle around it. And the black keys follow the same pattern. And as you can see here, for I in range length of black keys, we draw each key in its position using the prefix array. And if it is active, we also draw a green rectangle around it. These 4 lines draw the hand position borders, the red and blue lines we see on the keyboard. Next, we draw the key labels. First is the white keys. This is what you see on the final product that indicate which key you should press for which note. There are 8 white keys for each octave. I added a later one because you have to be able to play octaves on a piano, right? So for I in range 8, which iterates from 0 to 7, if it is the extra octave key on the left hand, then when the hands are positioned together, it does not exist. So to avoid that, we have to insert this if statement. I is equal to 7, which is the last note, and the hands are together, and the hand positions are right next to each other. then pass, or else the key label is rendered and then updated to the screen. And the right hand wide keys are much simpler because we do not have to consider the occasion which the hands are together. Next, we draw the black key labels. First, we have to determine where the key labels start and how many keys there are. Because again, if the right hand is next to the left hand, then the extra black key does not exist. So we go through all this logic to determine the first, where it starts, and second, the number of notes. And we pass the variables into the display black function, and then we just draw it. And the same follows with the right hand black keys. Now comes the part where we draw the switching indicators. It's divided into two parts. First, the shift key, which is the 0 position, needs to be vertical label. So that is what the first 8 lines are doing there. Next, we can just bulldoze the rest of the labels. So for I in range 1 to 7, we just put a label and draw a rectangle and update the label. And finally, because we edited the active white and active blacks list in this function, when we drew the green rectangles, we need to return them to the main. So that is how we draw the piano dynamically. And now let's look at how I switch the hand positions. First, we introduced the global variables into this function because Python has this weird mechanism that states that you can't call global variables inside a function, or it will assume it's local and say it's undeclared. First is the left hand, B, V for switching between octaves, and the rest is the various micro positions. And then there's the collision logic. First, if we want to shift up the left hand by an octave, we need to be sure that the right hand is not in the way. So, if the right hand is not in the way, which is this one right here, then just go up 1. If it is, then if the micro position is in the way, then we just smooch them together. Shifting down, there's no constriction. And for every one of these shifting up, then we need to go through the same logic. Is it next to the right hand? Is left note smaller than right note, or some other condition? And that is what all this is doing here. It needs to be this long because Python does not have a switch command, or if it did, this will not suit that scenario. And secondly, and the right hand follows much the same logic, except this time it's when it's shifting down. It needs to consider the collision logic with the left hand. And also, if it's in the rightmost position when right pos is equal to 3, then it cannot shift any micro positions. So that is what these consider here. And that is all the switch key function does. Now is the main function. It's an infinite loop which we only exit when there is a quit command. So timer.tick 1 FPS, which means that this loop will execute exactly 60 times per second. And then we initialize the screen, which really should be put in to the drawPiano function, but who cares? And this is the quit. Oh, before that, we need to actually draw the piano. Just call the function and we're done. And this is when we get all the keys that are currently pressed. And we need to see if there is a switch in position in either of the hands. So we pass the array, the list, into the switchNote function. And then we iterate through each button in the right hand to see if any of them are pressed. If it's number 13, which is the black octave key, then we need to figure out which one it is and then put it inside to play it. If it's the white octave key, then we go through the same process. Or else, if it's a black key, then we figure out which one it is and do the appropriate shifting, and then we play it. Also, if the key is in the next octave, then we need to subtract it by 5. Or lastly, if it's a white key, then we just do this normal thing. Fine. Then we need to actually play the note. Here I've indexed all the piano keys as one continuous list of playable mixers. So we first index that, and then if it is pressed, then we see if it's pressed in the last cycle. If it's not, then we play the note. If the keyboard is connected to a MIDI port, then we send a message, or else we just play the sound file. And last in this step is we set the played list to a value of true to indicate that this key is already pressed, and in the next cycle it will not be played again. And if it's a black key, we update the active black, and if it's a white key, we update the white active white. This can be done in one list. However, because we draw the black keys and white keys separately, the two arrays are better for this purpose. Or, okay, so the second case, if the key was not pressed, then we set the played list to false. And if it's connected to a MIDI port, then we stop the note. Or else just let it stop naturally when the sound file is played. And again, we update the display status. The same goes for the left hand keys. And that is it. That is the whole Python piano. So there you have it. That is my Python piano. It is based on LeMaster Tech's Python piano, which I will link his video down in the description. Also, I will link the GitHub repository also in the description. If you enjoyed this, please like, share, comment, and perhaps consider subscribing. Thank you for watching.